In this video, I will show how to work with an exponential model and answer certain questions. In this case, we have a model that represents a bacteria growth. The formula is given by the following relation, and immediately we recognize the continuous exponential growth as there is e involved in the base of this exponential expression. So to answer the question in part A, we simply have to evaluate the function at t equals 0, and the y-intercept is always the coefficient in front of that exponential expression. So the number of bacteria at t equals 0 will be exactly 1000. So to answer the question in part B, we again have to look at the definition of the function and interpret what's given, as the coefficient in front of the exponential expression is interpreted as the initial value. The coefficient of t in the exponent is interpreted as the growth rate. So the growth rate of this bacteria population is 0.01 per 1 unit of time, and 0.01 means 1%. So we interpret 0.01 as 1% per hour. So this is the continuous growth rate in this model. Now to answer the question in part C, we basically just have to evaluate the function at 4, meaning we have to plug in t equals 4 into the formula. So we have to evaluate e to the power 0.04, for which I'm going to use a calculator. So 0.04 e to the power, and multiplied by 1000, we get 1040.81. So after 4 hours, there will be 1040.81 bacteria. And I guess we may want to round it here, as 0.81 bacteria may not make sense. D, when will the number of bacteria reach 1700? So in part D, the question is basically to find the value of t when the output is equal to 1700. So we have to solve this equation, and to solve this equation, we basically have to take the expression that defines the function and set it equal to 1700. So 1000 e to the power 0.01 t is equal to 1700, meaning e to the power 0.01 t is equal to 1.7. 0.01 t is equal to ln of 1.7, and t is equal to 100 times ln of 1.7. And to compute this, again, I'm going to use a calculator. ln of 1.7 is 0.53, multiplying it by 100, we get 53.06 hours. So the answer is it will take 53 hours for bacteria to reach 1700 population. To answer the question in part E, we basically have to solve this equation. So when the population will double, meaning if initially it was 1000, so when will it double means when will it reach the level 2000. So that means we have to solve this equation, which can be easily solved by isolating t. So it is going to be 100 times ln 2. I'm going to use a calculator to find ln 2, and then multiplying it by 100 gives us 69.31. So it will take 69 hours and 3100th of an hour to double the size of this population. So this is how we work with an exponential function, and this is how we answer some simple questions about the exponential function.